Hello my dear NSEJS aspirants, I hope your preparation is going well, and here we are providing free NSEJS previous year questions discussions in this particular channel. And if you are new to this channel, just click on the subscribe button and watch the video. If you really like the content, just click on the like button and share with your friends. And if you wanted to join with us, just contact to the numbers provided on the screen and in the given in the description box. Okay, yes, you can also post your doubts in our Telegram group, which is given in the description box. You can join with that link and you can post your doubts there. We will be solving them and we will be addressing them. Okay, yes. So look at here, which are the following are examples of an acetal. So first of all, tell me what is an acetal. So acetal comes from acetaldehyde, or simply I can say aldehydes. Okay, you just take any aldehyde, not exactly acetaldehyde, you take any aldehyde. So aldehyde means we know it should contain one hydrogen definitely, and this side it can be any R group, alkyl group, or it can be a hydrogen also like formaldehyde also. Okay, so to this, if you add 2 moles of alkoxide ions, okay, so what we are adding? Alkoxide ions. So what we are going to get? R, see this is the electrophilic center now, so something like this. So your carbon will be having now one hydrogen, one R group, these are comes from aldehyde, and you will be having one OR here, something like one OR here and another OR here, like this. So this kind of species can be considered as aldehyde, okay, acetal. Okay, so now look at here, this is the carbon, okay, yeah, so this is the carbon where this side we have one OR group, one methoxy group is there, and this side also you have one OR group, one alkoxy group is there, yes, okay, and this side one R group, alkyl group, and one hydrogen is there, yes. So this carbon is considered as acetal carbon, so I can say this compound is an example of acetal. So first one is perfectly correct, perfect example of acetal here. And if you go for the next question here, I mean second option, so look at here, this carbon attached to 2 alkoxy groups here, one alkoxy group here and other alkoxy group here, and 2 hydrogens this side. Yes, this is also perfect example of acetal. Okay, so first and second are perfectly correct. Then next, third one you can just check. See, there is no carbon having 2 alkoxy groups directly attached. It means that carbon, this aldehyde carbon should be attached with the 2 oxygens first. Okay, this side one oxygen is there and alkyl group is there, that is what alkoxy group I am saying. But this side you have only carbon, okay, there is no oxygen atom. Right now this is not an example of acetal. Okay, and this is also, let's just look at here, one carbon you can write. So this side you have alkoxy group, yes, this is perfect, and this side also you have alkoxy group, this is also perfect. But look at here, here you have alkyl group, the carbon is attached, so alkyl group is attached, and this side you have methyl. So it means that is nothing but it is a ketal, not acetal. So ketals comes from ketones like R, C, double bond O, or if you add 2 O alkoxide groups now, so what you are going to get? So something like R, R, OR, OR. So this is something like this. So fourth one is something like this. So right now, so this is ketal, not acetal. So what are the exact options here? 1 and 2 are the examples of acetal. So first option will be your perfect answer for this question, right? Hope this is clear. Yes, if this is clear, just click on the like button. Okay, right. Next, here an alkane X contains 5 primary carbons and 2 secondary carbons and 1 tertiary and 1 quaternary carbon atoms. So identify the compound from the 4 options and tell me the IUPAC name for that compound X. So very simple. So now just try to write the structures of these 4 options. So first one, if you look, hexane they are saying, so write 6 carbons, so 3, 4, 5, 6 over, and they are saying 2, 3, this is 1, 2, 3, 4, 4 dimethyl. Yes, look at this. So this is a primary carbon right now. So hexane 5, 6, this is an hexane. Okay, so this is a primary carbon, this is also primary 1 degree, this is also 1 degree, 1 degree, 1 degree. So total 4 1 degree carbons are there. Yes, this is perfect. Okay, so as per their requirement, they are saying 5 they require. 1, 2, 3, 4, 5. Yes, 5 are there in the first option. Okay, and then next, look at this second carbon. So this second carbon is second tertiary now. So 1 methyl group. See, if a carbon attached to only 1 carbon directly, I can say that is primary. If it is surrounded by 2 other carbons, I can say secondary, and this is surrounded by 3, so it should be tertiary. Okay, this is one tertiary, only one tertiary group carbon, tertiary carbon is there. Yes. And next, what about this carbon? So this side one carbon, this is another carbon chain. So this is secondary carbon here, and this is also secondary. So how many secondaries are there? So 2 secondaries are there. So 2 secondaries are there, secondary carbons. Next, what about quaternary? See, this carbon is a quaternary carbon, it is surrounded by 4 carbons. So I can say one quaternary 4 degree carbon is there. So this is the requirement in the question they have provided. So 5 1 degree, yes, okay, and 2 degree, yes, 1 3 degree, yes, and 1 4 degree, yes. So option 1 is perfect answer for this question, and if you want you can check for the other options also, but as of the given question they are asking now, the IUPAC name of that X will be definitely 2,4,4 trimethyl hexane. Option A is perfect answer for this. Okay, yes. Let us move forward with few more questions. The number of isomeric alkenes with the molecular formula C5H10 is, okay. So also include stereoisomers, okay, taking stereoisomers into account. So count stereoisomers possible also. First of all, tell me C5H10, identify whether it is alkane or alkene. So it is an alkene, it is satisfying CnH2n kind of formula. So it is an alkene right now. So one double bond must be included in that. Okay, yes. So now write the structure. So we can write 1 2 3 4 5 and you put a double bond here. So this will be one compound I can get. Okay, and next one I am placing the double bond over here. Okay, 5 carbons are there, but double bond position is inside. Okay, this is terminal, this is internal. So here I can write, see, these 2 hydrogens are trans to each other, and I can place them cis to each other also. So from this we can get 1, from second structure we can get 2, one is cis, other one is trans. So 2 isomers are possible for this. Okay, next this is about 5-membered straight chain. So now just cut one carbon and make it a 4-membered parent chain, and put the other carbon as a substituent like 2-methyl butane, something like that. Okay, and put a double bond here. Okay, this is one structure and there is no stereoisomers for this now, and this is having no geometrical isomers or stereoisomers I can say, or optical isomers. So to this again I can place the double bond here. Right now these are 2 different possible structures. Okay, so this is also one more and this is one more. Okay, so till now we got this many, and any other possibility is there? Yes, check any other possibility. So I am writing a 4-membered chain. Okay, 4-membered chain with what we can do. See, I can place a double bond this side. Okay, yeah, this is also one more possibility is there. Yes, so till now how many structures we got? So 2, 4, 5, 6, 1, 2, 3, 4, 5, 6. So we got 6. Okay, so now they are saying 7th also possible. Let us check just once, try to draw the structure. So with the 4 number of carbons in the parent chain, these are the maximum possible. So just check, is there any other possibility? No, right? Yeah. So let us put a 3-membered chain like this. Okay, 3-membered chain is over, and we need to definitely insert a double bond here. Now tell me, where are the other possible ways we can keep? So here you can keep one double bond, one methyl group, and is there any other possibility? No. So if you put it like this, 1 2 3 4, so that is nothing but something like this. So this is not possible. Okay, and if I place here, so this is nothing but somewhere you have, this is nothing but this one. Okay, so it means there is no other possibilities. So what are the options, or what are the possible number of stereoisomers you can able to get for this particular one? So 6 are the maximum possible maximum possible isomers, including stereo can be possible. So 6 will be your option number C, will be your perfect answer for this question, right? Yeah. Let us move forward with one more question. The correct order of relative strength of the following nucleophilic species is. See, they have given this nucleophilic species. Always remember, we need to give the nucleophilic order. No? Nucleophilic means tendency to donate or tendency to attack on the electrophilic site. Okay, more is the tendency, more is the nucleophilicity. So wherever, see, tendency to attack an electrophilic site means if there is an electron deficiency site. So whatever the species having more tendency to attack on that will be having stronger nucleophilic nature. Right now, out of these 4, always remember carbon having negative charge like methoxide, like methyl carbon anion, okay, and here NH2 I am writing with negative charge, and OH I am writing with negative charge. Now out of these 4 options if they ask, so 3 options if they ask, see which is less electronegative, carbon now, therefore it is, since it is less electronegative, easily it can donate, okay, and see here it is more electronegative than the carbon, therefore it is the followed by carbon, and high electronegativity is for oxygen, therefore it is followed by this nitrogen, and if I have fluoride, so this will be the nucleophilic nature order, okay. It depends upon what? It depends upon electronegativity, more electronegativity, less nucleophilic nature, okay. So like that, based on this explanation, look at here, we have NH2 and OCH3, nitrogen is less electronegative than oxygen, so 1 is more nucleophilic than 2 I can say, okay. After this, see here also oxygen, here also oxygen, but this oxygen is in carboxylate group, it means it is in conjugation with the ring, this pi electrons of other carbon atom right now. So this is an equivalent conjugation we can say, therefore since electrons are less available to donate because they are in the conjugation with the ring pi like this carbonyl group, carbon and oxygen bond, therefore they are less available to donate to the electrophilic side, therefore I can say this is less nucleophilic than this 2, okay, I can write it here, this one, okay, and there is no charge, therefore no charge means this is least nucleophilic. So 1, 2, 3, 4 will be your answer. Where do we have? So 1, 2, 3, 4, option D will be your perfect answer for this particular question, right? Yeah, let us move forward with one more question here. Predict the major product in the following reaction. So tell me which is major product here. See, whenever you have an alkene treated with B2H6, okay, so B2H6 and also H2O2 in basic medium, so you are going to get hydroboration product, like remove the double bond and place one OH group at one carbon, other carbon hydrogen, okay. So this hydrogen comes from where? That comes from B2H6, okay, remember that, okay. Next, and this OH comes from where? It comes from H2O2, okay, yes. So this is secondary alcohol we got up to here. Now treat this with PCC. What is this PCC? It is a oxidizing agent, converts alcohols to ketones, okay. If it is a secondary alcohol, converts into ketone. Primary alcohol means it will converts into aldehyde, okay, yes, okay. So what is the product you are going to get? R here, and make this OH group as a double bond O. This will be your answer. Where do we have? Yes, here B will be your answer for this particular question. Hope this is also clear right now. Yes. So if all these things are clear, just click on the like button, and also you can share with your friends, those who are really preparing for these Olympiads, and you know, you can also watch the other content of this channel where we are also focusing on JEE, NEET and EAP set exams, okay. So you can have a quality content there for free of cost and all, okay. And if you want to join our batches where we have personal mentorship and all, you just contact to the mobile numbers given on the screen of this video or in the description box, or you can also join our Telegram group or fill the Google form given in the description box to get more detailed information about our batches, okay. Yes, okay. So yeah, this is the last question we have from this particular session. Look at here. The given compound is treated with hydrazine. So what this hydrazine will do? So hydrazine presence of basic medium, so we will be calling as a Wolff-Kishner reduction, that will reduces or that will converts C double bond O group to CH2 group, like this you are going to convert, okay. So like this, see, this group will be converting into CH2, methylene is formed, okay. So it means you just need to remove this double bond O, so that you are going to get a compound like this. Like this, okay. Now see, KOH is given in excess quantities. So what happens when it is given in excess quantities? So this will act as a strong base and abstract a acidic proton. See, we have an acidic proton here, so this proton is abstracted by the base, so that we will get a conjugated system by removing this chloride ion, okay. So now we get a benzene with a double bond here, which is in conjugation with a ring. Therefore, this kind of product here, option D will be the product formed in this particular reaction. Hope this is also clear. Yes. So guys, if everything is clear, you can also try the other questions of NSEC 2023 and NSEC 2024, and you can take the help of the videos that are posted in this channel. Just go through the playlist, you can get a lot of content regarding this NSEC, NSEP, NSEJS and NSEB and IOQM also. Yes. Okay. So thanks for watching. Stay connected with us. Thank you.